Algebra 2, 5.2a, Add Polynomials. I've got the previous videos for Chapter 5 in this video's description. You could just click on them, okay? I don't want you to become confused because you missed what we did. The sum of two polynomials can be found by writing a plus sign between them and collecting like terms. It's easier to add them stacked in columns so we can line up the like terms. And we can add polynomials with unlike terms. Just remember to write the sum in exponential order. So if we're adding two polynomials, if you'll notice the second one is missing an x term. It's got the x to the third, and it's got the y term, and it's got the constant, but it's missing this term. We just leave an empty space. Make room for this one to just come down, see? Then we add them in columns going straight down. It's important to line up the like terms so we can add them correctly. Sometimes when we add polynomials, there's lots of missing spaces. This second polynomial was only 5x squared plus 9. So we had to leave an empty space there, an empty space for under there, and the first polynomial didn't have an x squared term, so it had an empty space here. We left an empty space for the x term, and it didn't have a constant for the first one. And by combining these, even though neither equations had like terms, we were still able to write them in exponential order and come up with a sum. See? So we have to remember to leave a space for the missing terms. If we were to add negative 3x to the third power plus 2x minus 4 to this 4x third plus 3x squared plus 2, we've got an empty space here and an empty space here. Negative 3 plus 4 gives us our buddy the invisible 1, doesn't it? And we don't have to write that, do we? But he's there. We drop down the 3x squared. We drop down the 2x, and we add the constants and get a negative 2. And that's our sum. For this one, they all match up, don't they? And we just pay attention to the signs. The negative 5 plus 8 is going to give us a positive 3. And we just add them going straight down the columns. See? Remember your rules for exponents. When we're adding exponents with like bases, we just drop them down, don't we? When we multiply is when we start doing different stuff with exponents, isn't it? So this 4bx plus 5bx is just 9bx, okay? And for this one, we're missing a term right here, so we left space for it. This first expression didn't have an xy term. Remember, there's an invisible 1 coefficient in front of this one, so the 13 plus this one is going to make a 14, isn't it? We just drop this one down. We don't have to add it to anything. We add the constants, and we get a negative 2y, and now we have our sum. See? Isn't that easy? All right, take a look at this one. Now there's fractions. So in this one, we had two terms, and in this one we had two terms, but they didn't line up. There's an empty space here, and there's an empty space back here. We can still add them. We have 5, 6 dx to the 8th, and look at, we have a positive 2/3 dx to the 4th and a negative 2/3 dx to the 4th. You know what happens there, right? We create a zero pair. Those are additive inverses, and we can just cross that out. And we drop down our positive, our plus 1/5 d, and that's our sum right here. Okay? And what happens if we don't have common denominators? Well, just like in grade school, we find the common denominators. If we've got 3/4 x squared and 2/3 x squared, we just find the common denominator, a 12, and we have 9/12 plus 8/12. That gives us 17/12, or 1 5/12. Now we have 1 5/12 x squared. Same thing here. A half is the same thing as 2/4, so we add 2/4 and 1/4 and get 3/4. See? Just like we did in grade school. We add the x squareds together. We leave room for the x because there's no other x term, so that just drops down. See? Now look at this one. This one's a little more confusing. If you look at this, I purposely made each term its own color. So we've got p to the second, q to the fourth, but there isn't one over here. So we know there's going to be an empty space up front when we add them. This one has a p to the second, q to the second, and so does this one, but it's back here. It's got this one in front of it. But there's no green one here. It just goes straight to minus 3q, and that one doesn't have it. So what's going to happen is we're going to line up the p to the second, q to the second term, and it's going to come down, and it's going to come in front of this negative 6p q to the second. See? So we rearranged it so that we could put it in exponential order. Then this one was all by itself, so it just went into place in exponential order. The 3q went into place in exponential order, and we put in the constant. See? So sometimes you might have to move some terms around in order to get them in exponential order. You want them to be either in ascending or descending order. So you want the exponents to be either rising or going down in order, okay? And descending is the normal one, all right, that you see in your books all the time. So just make sure the like terms are all lined up, and if you don't have like terms, leave a space and rearrange the terms if necessary. Like we did here, we had to bring this one in the front because p squared has to come in front of this p to the first, see, in exponential order. I'm going to add this video to the Algebra 2 playlist, and you'll be able to click on this video's description to get to it and to get to the Chapter 5 playlist from Algebra 1 from last year when we talked about exponents and polynomials. And of course, there's going to be links to those previous videos for 5.1a, b, and c. If you missed those, you really should watch those before you watched this one, okay? All right, we're going to move on, and we're going to talk about additive inverse of a polynomial, where the whole polynomial is an additive inverse, okay? I'll see you there. Bye.